I'm Val Bercovici with NetApp, and my title is Cloud Czar. That's kind of an icebreaker I use. It's more interesting in Cloud CTO. It turns out it's much easier to become a czar than it is to remain a czar. Becoming a czar is easy, especially at an enterprise like NetApp. You kind of raise your hands. You're one of the first to raise your hands and say, hey, this cloud thing about 3 or 4 years ago looks like it's real. Let's do something about it. I can't claim to be the first, but I was sort of one of the more popular people to do the same thing around big data about a year ago. But one of the ways you stay a czar is predicting the revolution and staying ahead of it. So I know that there's an interesting tension, a creative tension between NetApp over the past 4 or 5 years striving really hard to be established as a big iron-style vendor in the enterprise for storage, and quite frankly, a lot of shared virtual infrastructure the past few years. And yet, big iron is the very antithesis of the Apache community, the Hadoop community, open source in general. So this is actually pretty cool for me. One of the things you may or may not know about NetApp is that we are very much an engineering-driven culture. It's the largest department in the company, consequently, one of the most politically powerful departments within the company. And quite frankly, we're all geeks. We're all propeller heads. We love technology. And communities like this let us, let our hair down a little bit and let our geek hang out a little bit. So let me give you an example. We actually have a very, very prominent track record of contribution to the open source community. I'll start with one of the more recent examples. Anybody heard of a little company that's planning to build a spaceship-like structure in Cupertino? So they, amongst other companies like NetApp and Juniper, et cetera, use the BSD kernel quite heavily with all of their products. And recently, in my hometown of Ottawa, Canada, at the BSD kernel summit a couple of weeks ago, NetApp contributed the first and only production-quality hypervisor into the BSD kernel. We developed the code, worked with the community, and contributed it freely without restrictions to the BSD community. That's just one example. Another one, actually, is even more interesting, Linux and NFS. For those that know NetApp, we certainly cut our teeth on and grew up by providing the world's leading implementation of a network file system for Unix and Linux. And yet we faced a dilemma as we grew up and our customers asked us to solve bigger and bigger challenges. They wanted us, for example, to run transactional Oracle systems, high-performance OLTP systems over NFS. We said, sure, we could do that. Well, it turned out we were only half right. We developed and maintain still what we think is a leading NFS server implementation in the industry, but it turns out you need a client to make that work as well. And there was no motivation for competitors of ours, such as Sun, HP, early on even IBM, before they became a partner, to develop a robust NFS client, because none of their storage configurations going over Fibre Channel or SCSI back then utilized or stressed that functionality. So we put our money where our mouth is, hired some Linux developers with NFS expertise, and through the meritocracy that is Linux, earned the right to be the lead maintainers of the NFS subsystem in the Linux kernel. And we continue to fund that project. We certainly hardened NFS 3 to the point where a lot of mission-critical production applications are run. Probably one of the coolest references you might want to Google is at CERN, and some of the stuff they're doing with a Large Hadron Collider, running Oracle over NFS on NetApp. And yeah, if you want to tweet, if you have a sense of humor, when the black hole finally comes and the end of the world is upon us, NetApp can be responsible for that. So feel free to tweet that if you'd like. But that's just one example. So I say that to say that we plan to do the exact same thing with the Apache Hadoop community. We will earn the right by transparently contributing to the community to be one of the foremost experts and ideally contributors of all things storage and file system related. And this is not about NFS versus HDFS in any way. It's very much about the emergence of HDFS as this next-generation networked file system, literally designed from the ground up to handle big data economically, efficiently, with high performance in ways that a 30 or 40-year-old POSIX file system design was never intended. Now, big data. Certainly, this term is becoming as overhyped as cloud was 3 or 4 years ago, and consequently, at least as confusing. We don't believe it's a vendor term, actually. So please don't judge us as harshly as some of our peers or competitors in the industry that are trying to co-opt or hug this term and just abuse it for marketing purposes. We very much believe this is a community, open source derived term by the open source community, in particular, solving business problems that commercial solutions couldn't at any price. That, fundamentally, is what NetApp thinks is cool about big data. Having said that, though, looking beyond the application layer that my colleague Anand at IBM illustrated so nicely this morning, at the workload layer, because we really care about workloads and how the I/O patterns applications generate impact storage from a performance, availability, efficiency perspective, we're able to dissect big data into the three ABCs, well, the ABC, comprised of three simple things: analytics for A, B for bandwidth, and C for content. And think for a minute the way the data flows. Today, machine-generated telemetry, large streams of unstructured and structured data, and particularly big bandwidth, giant video systems. The way we ended up identifying Osama was a giant eye in the sky with some outlandishly high definition, high resolution, continuous video feeds coming at us on the order of tens of gigabytes, not bits, tens of gigabytes per second per pod. So think of analytics and data as giant fire hoses of information that are being generated. Now, you can either just let that water pass you by, or you can actually try and capture it. And big content is all about creating a bucket with an opening big enough to both literally and figuratively not be a bottleneck. That's what it breaks down to from a storage perspective. So I know this room, I know my audience. Everyone here has seen the Social Network movie. Everyone here remembers the line that Justin Timberlake uttered as playing Sean Parker. You know what's cool? Not $1 million. What's cool? $1 billion. Thank you very much. So I think it's super cool from a geek perspective to hear what Yahoo is doing with this technology and how they're evolving it, to hear how Facebook is applying it, to see what other major leading implementers, or LinkedIn, et cetera, are doing with this technology in the web space, Twitter, and so forth. But what's really cool for a for-profit enterprise like NetApp is seeing this technology go mainstream. So IBM alluded to some of the industry verticals. Think about Winnebago in Iowa. I've been there. I've visited them in the middle of a snowstorm, actually. As they started adopting Hadoop, think about Airbus in Toulouse, France. Think about Reliant Communications in India. Think about Kaiser Permanente here, or Citigroup. Think about the bricks and mortar companies for business-critical or sometimes mission-critical applications adopting Hadoop. That is what's really cool. And all those businesses have machine-generated and other sources of big data coming in. All of those businesses have big bandwidth requirement. Fundamentally, the large block size up to 256 meg of HDFS ends up being a big bandwidth I/O workload for any storage subsystem. And content, of course, after you curate the data, after you analyze it and curate it, there's always going to be, hopefully a large subset, maybe a small subset, maybe even somehow a superset of data that you care about and never want to lose. Those are the three specific areas of value that NetApp is focusing on, generally in a big data landscape and specifically within Hadoop. So before I get to a couple more product-level details, I do want to remind people, because it was just a one-time news item, so not everyone might be aware, but NetApp grew up with some core technologies, the Data ONTAP storage operating system, the legendary Waffle file system. We recently made an acquisition that has changed their ideology significantly. We acquired the Ingenio external storage product line from LSI Logic, This is the storage behind every major high-performance application in the industry. And Teradata, for example, uses this storage exclusively for their structured analytics engine, and we'll soon use it for some of their unstructured analytics acquisitions as a part of Aster Data as well. And I can go on and on. All the work that IBM talked about earlier on was based on this same technology, the E-Series now from NetApp. And this is a storage platform ideally suited for big data workloads and specifically for Hadoop. And not the least of which is when we're talking about market share and market influence, NetApp, by virtue of this acquisition, essentially bought leading market share in the structured analytics space. And we're learning a lot through this right now. We're collaborating with the engineers from Ingenio, and we fully intend to grow our lead in that space. The other thing I'm immensely proud of is actually being part of the HortonWorks announcement yesterday, working with Eric and Sanjay and Arun and team, Owen and so forth. Really, really impressed with their vision. For those that haven't read their manifesto, it's on their website. Go have a read. It's a strong, powerful, transparent, and passionate vision for where they want to see the community going. And NetApp, it perfectly aligns with our vision as well. At the end of the day, as a storage infrastructure supplier, we don't necessarily want to have to pre-configure and support dozens of different distributions. There's a lot of economies of scale for us if the community unites. And that's one of the reasons why we do strongly believe and will make continued high-profile investments in the Apache Hadoop community. We're also looking at beyond MapReduce and HDFS towards enhancing the capabilities of HBase in general and other structured analytics projects that become part of the Apache community. So what does a product look like? It's a very, very simple and modular product. It is not the big data ONTAP operating system in Waffle that's optimized for shared virtual infrastructure through VMware, Xen, or KVM. This is really about an HDFS optimized modular storage appliance. And the real benefit of some of the hardware offload here is the ability to separate data protection from job or query completion. And it doesn't mean monolithically separate data protection from job or query completion. It gives you the flexibility to have any kind of rep count you want through the various phases of the application. You might want a lower rep count to minimize top of rack networking traffic as you're ingesting data at tens or hundreds of gigabytes per second in aggregate. You might want a lot of high rep counts when we're actually doing crunching of numbers and transformations through MapReduce phases. And then once the data becomes cold and you have a long tail, storage efficiency starts to matter. You might want to reduce the rep count on that and rely on hardware and perhaps erasure coding as it makes it into the HDFS distributions for data retention and protection. The other thing that's worth noting as well is that as the Facebook open storage specification becomes more and more public to complement their open compute work, it's going to bear a striking resemblance to this architecture. So that's a clear indication, even though we've worked independently at Facebook on this design, that we're headed in the right direction. And as you're seeing with the MapReduce.next and some of the HCatalog work and other roadmaps from other big data vendors, as these systems scale, separation of job completion, application management from resource management, and separation of compute from storage is the way GFS2 is scaling, is the roadmap forward for Hadoop and other distributed file systems to help you balance appropriately the number of compute and storage resources and not have an excess or lack of either as you support multiple tenants and multiple applications. So to wrap up, our strategy is to be open, very open. As we're seeing here today, this is a vibrant community, a very diverse community. We haven't even heard from speakers from LexisNexis proposing alternate MapReduce schemes. We haven't even heard, I don't think yet, from Cassandra proposing alternate file system layouts and so forth. It's too early to overcommit to one specific solution here. So a hardware-compatible option with all these various proposals being put there that will evolve transparently through meritocracy for ultimate success, that is sort of the most risk-averse strategy enterprise customers can adopt. That is a constituency in the audience we're targeting. It's the ability to choose your distribution, the ability to decouple the structured and unstructured analytics engine decisions, so you don't have to be bound to one if you choose the other. And of course, the ability to choose either a Cisco, IBM, HP server, or if you're a Supermicro Tyan fan, you can choose those as well. That's really key. Removing the configuration uncertainty at setup and scale, and again, decongesting the top-of-rack cluster network as you separate data protection from job completion is a huge advantage with HDFS. And with that, I know I'm out of time. I'll let the voice of God tell me if I have time for a question or two.
I'm afraid not.
There you go. Well, thank you very much for your time.